The dot product has many properties, most of which are, well, a lot of which are very similar to the basic multiplication properties that we have for real numbers. So here, first of all, we've got the commutativity property, that the order that you do the dot product does not matter, that they're the same. Here we've got a distributive property that this product of u, the dot product of u with the sum of v and w, you can distribute the u to each of them, and then add those. Here we've got something that looks like the associative property, that if you have a scalar multiplied by the product, that scalar can be grouped with either one of those vectors first, and then do the dot product. Of course, the zero vector, which of course is just the vector with no magnitude, so each component is 0. The product of that with any vector is 0. So those four properties are very similar to properties that we see with just real numbers and products. The rest of these are specific to vectors. Here, if you take a vector and do its dot product with itself, you get the square of the magnitude. And that just comes straight from the definition, right? If you take a vector and do the dot product of it with itself, let's go ahead and look at it. Okay. Well, you'd multiply corresponding vectors. So we'd have a squared and then plus b squared. And of course, we know the square root of that is the magnitude of the vector, and so that's why we have this magnitude squared. And then here we have, if you take a unit vector and dot it with itself, you will always get 1. Okay, and that comes back to this property right here that, well, if you take a vector and dot it with itself, you get its magnitude squared. But for a unit vector, that magnitude is 1, and 1 squared, of course, is 1. And then finally, the unit vectors I and j, the dot product of those with each other is 0. And when you get 0 with a dot product, we have a special word for that. We call those vectors orthogonal. Okay, I'm going to write that here in general. If v dot w equals 0, we say that v and w are orthogonal. Now, what that actually means in terms of geometry is that the vectors are perpendicular to each other.